We are just going to start with a new chapter that is about the function of several variables. This is not something new. We have been dealing with the function of one variable, two variables, three variables. We can extend it mathematically to function of n variables. So when we say we are a function of one variable, for example, like I take the area of the square, and the area of square I have here having the value x. So I know that my area is equal to x squared. Now when I want to change the value of x, the area is changing. So it's changing with x. I say it's a one variable, and x, by changing x, we are going to change the area of the square. So if I take here the rectangle, so in rectangle I have two variables. I have variable x and y. So we say area is equal to x multiplied by y. Now when I fix my y and change my x, the area is changing. I fix my x and change my y, the area is changing. I change x and y both, the areas are changing. So there are three possibilities, that either I fix my y and change x, or I fix my x or change y, or x and y both are changing. So the area of this one is changing. So we have the example. For example, I'm having a cylinder. In dimensions, I am having the height of the cylinder, and this is my radius of the base area. This is my r, and this is my h. And I want to find the volume of the cylinder. Volume of the cylinder is pi r squared, that's the base area, and then multiply by height. So this area of cylinder is y equal to pi r squared h. So here again, when we want to change our area of the cylinder, volume of the cylinder, then when we change our r, the volume is changing. We can fix our x, h, or we change our h, fix our r, then the volume is changing. So this is how we can say that we have a function of two variables. In graph, when we say here, we can take this as x-axis, y-axis, and this my x-axis. And I am having here any function that can be described by the function f x, y. This is my origin 0. I take a curve. So I take here the value of x. I get here corresponding value of y. And then this point is, I say here, y is equal to the value of the function yx. And this I say all the points. I say this is my curve C. So I have the definition here that I have two variables. One variable is my x, and other variable is my y. So these two variables must have different type of character. So I say that whenever a variable I'm taking along x-axis, I say that's independent variable. When you change x, the value of y is changing. That's the idea. When you change x, the value of y is changing. So x is independent, y depends upon x. So we say x is the variable, we say independent variable, and then I take the second variable. My second variable is y, so my y is dependent variable, because the change in y depends upon change in x. So we say this is my dependent variable. So I have the function y equal to f of x. I say my x is independent. Similar to this one, we extend this one. I can take here function z is a function of x and y. So this is a function of two variables, x and y. So here I can say the x and y are independent variables, and the variable z that depends upon the value of x and y, we say that is dependent variable. When you want to sketch the graph, if students of engineering or chemistry or physics, there are two types of quantities. One quantity is depending upon the other quantity. For example, we have the quantity pressure and temperature. We say pressure is depending upon temperature. When we say pressure is depending upon temperature, it means when we want to sketch the graph for this one, then the temperature will be coming along x-axis and pressure will be coming along y-axis, because pressure depends upon temperature. If we take opposite, the temperature is depending upon pressure, then pressure will come along x-axis and the temperature will come along y-axis. So we have to check which function depends upon what function. Then we say the function which is depending upon that will come y-axis. For sketching the graph, that's a very important point. You must learn that one. So we are having here the function of two variables. We are having function of x and y. Z is the function of x and y. Say x, y are the independent variable, and z is. We can have the function w, and we say function w is a function of x, y, and z. Now we are having three variables. Three variables are x, y, and z. I say three independent variables. Our w depends upon x, y, and z. So this is a function of three variables. Similarly, in general, in mathematics, we say our w is a function of x1, x2, x3, and so on, xn. So in general, we say the function of n variables, say x1 to xn. We can extend this one theoretically. And practically we say, well, the function of space having 3 variables which include time, the function relativity, function of 4 variables. So that's all we are having here. But we can have any phenomena which is depending upon different quantities, and the quantities are varying. So we want to make some calculation there, we need it. So here we can see there are two things we have mentioned, that we are having the independent variable and we are having the dependent variable. So as we have done in the function of earlier calculus 1, we have discussed the domain and we have discussed the range. The structure of the function that depends is defined on x-axis. We say that's the interval, and we say where the function is defined, that we call the domain of the function. And the value of the functions, we take all the set of the value of the function, we say that is our range of the function. Similarly, when we have two variables fx and y, there the xy is a point. So the point they are coming in xy plane. So we say this domain is all values of x and y on which the function is defined. And the value, when we put x and y, the values we are getting, that we say that is the word, that give me the range of the function. That the result coming from the substituting the values of x and y from the domain of the function in the function, this value will be the range of the function, and so on. So some important points about the domain of the function is that we will discuss the domain, then we don't take the denominator as 0. For example, I just take here f and g. So we say here our g must not be equal to 0. The point where g is equal to 0, these are not in the domain of the function. Similarly, we have the root sign, we have here g. So here g must be bigger than or equal to 0, must be positive. Must be positive. If it's negative, it means it's not defined. For lane function, for you take value of g, then the condition of g must be bigger than 0. So then this gives me the domain of the function of lane. So these are the points we have already studied in our earlier course of the calculus for finding the domain. The same thing we will be applying for 2 dimension, for 3 dimension, for any dimension. So these are the things we have to take care of that one.